Hi, Sydney.
Okay.
I was muted. So, hello, everybody. Good to see you again in our Milturn webinars. And as Sydney already said, this is the part one from a series of 3 or maybe 4 webinars in the future. We have so many improvements, so many change in 2016 version, so it's impossible to show you all of them in only one webinar. So we'll start step by step, showing you and make you familiar with all the improvements and sometimes also a changed way to work and to define our part and changing technology even, because all this improvement and changes in the software was done in order to support more complex Milton machines. We already have a wide range of machines that we support, but all the time the machines become more and more complex, more and more devices, more turrets on the machine, more tables, synchronization is going to be more difficult. So in order to support all this, we need to um, develop all the time and to change the software and add more and more options. I will start today with you to create a part, and step by step working on the part, I will also show you all these new developments. Today we will start to work on a standard machine that we already support in previous SolidCAM versions, DMG Moriseiki MTX 2000, and with this simple part, let's start to create the part. I will create a new Milturn, work external metric, all these settings are defined by me automatically in SolidCAM settings. First of all, we create the coordinate system, and here is the first improvement that we are going to talk. In previous versions of SolidCAM, we need to create one coordinate system for each submachine. For a machine with 4 submachines, upper turret, lower turret, and main spindle and back spindle, automatically we have the option in SolidCAM settings to create 4 coordinate systems for each submachine. And I think you remember, all of you already work with previous versions. Coordinate system for main spindle with lower turret was with X. In opposite side, we have on the opposite side of part, again, 2 more coordinate system for back spindle. You can still work in this way, who start to work and love the idea. There is no problem, you can still work in this way, but the new way offers you the possibility to work only with one coordinate system. And why is better? Why working with one coordinate system is better? It's better because in the moment you define a geometry, let me continue to define also the stock, and it's a relative, a cylinder, and we have 2 millimeters here and 10 and 2 on the external. Generate for me an envelope. Improvements in envelope and cylinder generation. There, in this version, all these are very fast and much faster than the previous versions. And also the target with the envelope. envelope building, and it's ready. Now we are ready to work. Now, as I start to tell you, working on upper turret, main spindle, with coordinate system, Mach 1, position 1, when I define a geometry, if I want to change this operation and move the operation from upper turret to lower turret, it means it's going to a different submachine, a different coordinate system, a different Mach. I need to redefine the geometry, because the defined geometry was assigned to Mach 1, position 1, to coordinate system of upper turret. I cannot use it in lower turret submachine, so I was needed to define a new geometry. Today, now I can work with the same coordinate system, with the same geometry, and I will demonstrate you now. But before that, the first step is to define the machine setup. And also here you can see a change. We don't have, as in previous versions, 4 submachines, and for each submachine we assign the coordinate system. No, we have here only the tables, because the mounting, the setup of a fixture and the stock is defined today on the table. I have only 2 tables. So I have set up when the part is mounted on the main spindle, and set up for the part mounted on second spindle, we call it back spindle. Before that, you remember you have here 4 submachines, for each one of them a different coordinate system and a different Z position, X, Y, Z shift. No, it's much easier, much faster, defined by table. Also, what we have here is this button, machine preview. We can see here in the machine preview the entire machine. We use in machine preview the STLs from machine simulation. I can see here exactly the machine and how I will mount the part on spindle. The part is now mounted in 0 position, in the center of the chuck. As shifting from the setup will show me exactly where I am. So if I define here 50 millimeters, I already see how the part is mounted on the machine. All these changes are done on the run in the same moment. So it's much easier to understand the mounting and the setup. Now, of course, we need to define a fixture, jaws, for each one of the tables. So I will define, let's close for now the machine preview. I will define a new fixture and take from the library also generate the envelope, catch for me the part in Z, let's say here, okay, and also we define a new clamping device, fixture, the jaws for the back spindle. Number 1, and it's a mirrored version. Take from the library and generate also the envelope. Okay, here I did a mistake. I don't want, when I am on the back spindle, I don't want to catch the part on the stock, because here it will be already machined. So let's go and fix this mistake. Axial clamping diameter will be, let's say, on 20 millimeters. I want to clamp the part on this face, on this hexagon. So it's a 40 millimeter distance, 20 millimeter in radius. Now recreate the fixture. Okay, regenerate the fixture. Now, in order to mount the fixture and the part in, let's see, in the machine preview correctly, I will pick this edge will be on the main chuck. Okay, we already see the machine preview is updated, the fixture is on the main chuck. The same we do with the back spindle. Pick this edge will be on the back spindle. We take the value and we finish. Now, another change here is in the setup, we define where is the stock, where I will start to machine this part, on the main spindle or on the back spindle. This is the place where we define this. Stock is on the main spindle. Here I start to work. Because if you select the stock is in back spindle and you generate the first operation on main spindle, you will get an alarm, an error, alarm message. You don't have a stock. You define an operation, but there is no stock on main spindle. Okay. We have the setup. Let's hide those envelopes and we can start an operation. But before this, I want to show you the machine. We work on NTX 2000 from DMG. That's a standard machine with a B-axis, upper turret, and the lower rotary turret, main spindle and back spindle. Standard, we will go step by step, and in the next webinars we are going to show you more and more complex machines and the solutions that we developed in order to support them. Another change in VMID is the structure. In previous versions we have the device. We still have this preview here, machine tree, axis on device. So we have the device, and on each device the axis. But as we already see in previous webinars, an example is the Index R200 machine, where we have two types of turrets on the same axis. I have a linear turret and I have a B-axis type turret. Two turrets on the same axis. And in order to define this machine, I needed to define twice two turrets and to copy the axis, the same axis with the same information and properties twice. Today, now we have only the axis. We start with the axis, and on the axis we mount the device. So I can have two turrets mounted on the same axis. I don't need to define a double Z1 double Y because I have another turret. Here on this B I can add another turret, and I have one turret, two turrets. This is linear, this is spindle, different properties, but they have common axis B, X, Y, and Z. This change, it's giving us more options to define more complex machines. So this is one of the big improvements. Let's delete this one. I don't want to change my machine. And we have more. We have a definition of drive unit, where you can define a number of gears. You wasn't be able until today. And to define for each station how this station, what is the drive type for this station? Is self-drive, it's a gear, it's drive direct from the drive unit. More and more options to define a correct machine for each station, different properties. I will not start to talk today about all these properties in VMID. This is a subject of the next webinars, just a sneak preview for what you are going to see in the future. The properties also, we know that until now we wasn't able to define different options for each submachine. A machine can have compensation with upper turret, and compensation for lower turret is disabled. It's not working, it's not active on the machine. So we have the possibility today on each submachine to define different properties. Arc. One submachine can work with arcs, in another, no, it cannot create with arcs. So today, each one of them with each submachine with his own properties, and more changes and improvements. Okay, but again, this is an entire subject of one of our next webinars, and is more for the advanced users who want to know and who want to understand his machine, and sometimes who want to change something. But for standard users, it's not so important. You don't open the machine ID every day. It's not in your use. But for anyone who is interested and want to understand, we will explain this in one of our future webinars. Okay, let's start to define an operation and demonstrate you how we can change very easy from one turret to another turret. That's a SolidWorks bug. That's happened. We work today on Windows 10 and with SolidWorks 2016, and sometimes new things are buggy at the start and the beginning. All this new environment is new here. Windows 10, SolidWorks 2016, and SolidCAM 2016. SolidCAM, the recent parts, okay. Hide and hide also this. We don't need them. Let's see if the setup is saved. Yes, nothing changed here. Everything is okay. We were at starting to define an operation, a turning operation. We work on submachine upper main, the same way that you have in the previous version. You select the submachine, define the geometry. Let's work on face, and modify. We'll extend it to the stock. Tools. Select. Now we have an empty tool table, but let me import tools from, no, I will not work in inch. Let me import from this tool table all the tools, and I have tools on upper turret and I have several tools on lower turret. And now this is the tool picture, the same as in previous version, but the mounting here is the surprise, the big surprise. Today you are able to see all the tools, exactly how they are mounted on the machine, on the specific turret, and to see and to check if there is any collision, if the tool is mounted correct, as exactly as on the machine. So I define here 80 degrees insert, I have a 55 degrees insert, and each time I will click on a tool, this tool will be selected and bring it to the work position. So now I'm on station 1. Tool number 4 is station 1. I'm going to do station 2. Station 2 is on the work position. It's like browsing the tools. Click and the tool is, we bring the tool in work position. This is my tool. I can look if the holder is mounted correct, if the tool is correct, if there is no collision with the machine covers, because that's happened oftenly. If you have a long tool rotating the turret, the tool will have a collision, will crash into the machine covers. So here you can see everything. That's a new way, a better way to manage the tool table. We can hide all the tools and look only the selected tool. And the selected tool, I have tool number 9, station 6. I want to see all the tools. I will see all the tools. I can focus on this specific tool. There are so many options here to mount the tool, to create a new tool, to mount, to attach a new holder, and work in a correct way. Also, I can move axis. I can use a rotary turret axis with your mouse wheel. You can rotate this turret. You can move X. And when we are reaching the limits, the device become with red color. It's going up and bring him to 0. If I'm going to a positive, it's limit alert. Also with Z-axis moving. Now each mouse wheel rotation is 1 millimeter. If you use control, is going 100 millimeters. Control and shift going tenths, 0.1 to. In this way, you are able to bring the tool, the device, to a very precise position. Okay, also move. Let's look on upper turret. We can browse in the same way the tools. I have tool number 1 in the upper turret, tool number 2, it's a different tool with 55 degrees insert, tool number 3 with 35 degrees insert. We browse all the tools and they are mounted on the spindle. A milling tool, a drill, we can change the angle, move the B-axis. All the information is connected to VMID, STLs from machine simulation. We use all this information in order to give the user the possibility to understand the kinematic and the exact situation that he have on the machine in this moment. So we are here to select a tool. I will select tool number 1 on upper turret. And geometry selected, technology is on face, rough, save and calculate. Let's see the simulation. Simple face turning operation, but now I'm changing my mind and I say, oh, I want to work with lower turret. With upper turret I want to do different things and to use the different tools. I want to do it with lower turret. Now in the past, in the moment that you change the submachine, coordinate system was changed, geometry disappear. You have a new coordinate system, you need to define a new geometry. No, today you just change the submachine, the geometry remain, the modifying, the technology, you don't need to change anything. You just need to select a new tool. So I'm going to select tool number 4 from lower turret. Let's see that this tool, yes, it's a tool that I can work on main spindle. I will select it, save and calculate. Feed to large, okay, data, feed to large. It's something in machine ID maybe. Let's check. Let's check on the lower turret, Z-axis, view units on millimeters. Yeah, something very small defined here. Let's say 20,000. I'm not sure what exactly the the limit is. On X is okay. We have 30,000. Let's copy the same value also in Z. Save and exit. Calculate. Okay, now we don't get. We have in VMID the feed limit was defined incorrect. So I changed this operation. I moved this operation from upper turret to lower turret with only different tool selection. Nothing here. All the information was preserved in geometry, extensions, links, anything that you defined before, you don't need to define again. So this is one of the major improvements in the mill turn for these complex machines. Move this operation from one submachine to another in a very fast way. So I have the face operation. Let's create also a new geometry. create a long operation up to, let's say up to here. That's enough. And modify, start, and here another 2 millimeters. Tool, I will use the same tool. Save and calculate. Technology, need to change to long, only rough, no finish. Because for the finish, I want to use another tool, a different tool. Save and calculate, exit. Now, those two operations I will copy and paste. And here, first of all, I will select a new tool. Select the tool number 5. Let's see, it's a 55 degrees if I remember. Yes, this is my tool, 55 degrees. Insert, select tool number 5, and technology, finish only. Save. I can use compensation also. Technology, exit. And the long turning operation the same. I just need to bring the new tool, tool number 5, and in technology to change to finish only. Also can select compensation. So let's see what we have until now. Let's simulate. Okay, something wrong with my clamping device. Show me. That's the clamping device. And here is correct mounted. In machine simulation in this build seems to be a problem. Calculate. That's happened when you create a part online. Simulate again. Let's try one more time. Now is okay. It was a problem of refresh maybe. Move list. I will hide the machine and start working, change the tool, and we finish. Now let's create a milling operation, a profile on upper turret main, and use here this geometry, constant Z propagation. This is also an issue of a webinar, not a Milton webinar. This is a general change in SolidCAM. It's also related to milling, Milton, all other modules. An advanced way to pick a geometry. So we will not talk about this in deeply here, but if you will attend one of our future webinars, you will get a detailed explanation on how to use and what's new here. This is our geometry tool. Let's select the tool. I want tool number, it's a milling tool, 10 millimeters milling tool mounted on HSK 63 ER20. Select levels from this level down to this level, and the link, okay, I like a big radius, only 45 degrees with no distance. And let's look at the geometry. It's from inside, left, right, on the right. Okay, that's better. Now, let's simulate again and see the problems. I have 4 turning operations with lower turret, and now I came to with upper turret. Let's go directly to the last turning operation, and now I come with upper turret to work on this contour, and I have a collision. So I can see it clearly, and I will define an MCO, a machine control operation, before the upper turret. I will send the lower turret to a safe position. Add the machine control. First of all, main spindle, it was rotating after the turning operation. Well, rotation off, and lower turret movement, go to home reference in X, go down, but I can also see exactly what I'm doing here. So and the way that you know until now is define the movements here in the list, and everything is gonna be okay. But you need to know exactly what you want to do and what the machine is supposed to do. But with our new machine preview, you are going to do all these actions and device movements here. 0, I'm going to home reference 0, the turret is going down. Now I want to move z-axis for this turret. Z-axis, okay, I'm here. Update the machine. Okay, but I have here the z-axis is going to 0, and now I will move. Let's press Control. That's enough to 655. This position is enough for me. And this button will paste the axis values, what I select here, to our program in machine control. So I'll do all the movements here and paste the values. Now this 0 is not needed because it's already selected. Only Z is needed. I send the lower turret to a safe position. Save and calculate. Now let's try again without collision. Okay, so I will jump directly to turning operation number 4. Finish the turning, and in machine control operation, X is going to reference, Z is going to minus 655 in machine coordinate system. And now upper turret can start working on face of this part with no collision. Okay, now let's try to transfer this part to the back spindle and see again how this new machine preview can help us to do it easier. Adding a new machine control, and we are working on upper main. This is our last submachine. Upper turret. It was working before. The last operation is a milling operation with upper turret, so I will shut down the spindle and start moving the device. I prefer to use machine preview. I'm going to send the x-axis, x2, x1 to 0 to his home reference. B angle is already to 90 degrees. I don't need to move it, but I can move z-axis a little bit. Here, let's say, paste the values. And I can play with the order. So first I will want to move the x-axis, delete it from here. After this, y and z. B, I don't need it, is already 90 degrees. So upper turret, all the movements, after all the movements is in a safe position. Now let's handle the spindles. Main spindle. First, the working mode. I want to control C-axis. So if you want to control C-axis, the C-axis need to be connected. The working mode will define that for us. Milling or turning. I'm in a milling mode. C-axis is connected. And movement. Working mode, main spindle, upper main. The part, what's happened here, I select the movement and you see a different color here. Told us there are no movements to show in this view. Why? Because the part is mounted on this spindle. When the part is mounted on the spindle, I have to use part move because I don't move only the device. Device will not move alone without the part. Part is clamped in the jaws, so I need to use this function, part move. You make a mistake, SolidCAM will correct you. C 0 degrees. Okay, so the main spindle is in position, upper turret is in a safe point, back spindle. The same working mode. I want to work milling, is connected, and here I'm allowed to use the movement because on this device I don't have the part. It can move alone without the part. Movement is allowed. Let's start to use the preview. W. W is too many axes on these machines. Here is W. I will use control and move steps of 100 millimeters to come closely to the part. Let's zoom in. So with rapid move, I want to be before the part. Let's see here. Paste values. And C-axis, let's see, the C-axis, I need to rotate to 30 degrees. I don't see it here. Maybe I need to update the stock. Okay, now stock is updated. Yeah, this edge, this hexagon is not parallel to Y. So I don't want the jaw to catch the part on this edge. I want on this surface. That's why I will rotate the C-axis, C1. W was somewhere. Was here. Okay. And C, 30 degrees. Paste the values. I don't need this and this, no. Now, this movement, what? Back spindle working movement. It all gone away. -1375 and -30 degrees with rapid. The next movement will be inside and to catch the part. And again, let's zoom in to see exactly where we're going. 1 millimeter by millimeter, that's enough. 1408. I will copy only this value, Control C, and with feed 100 millimeters per minute. Now in this position, I will clamp the part on stock. That's also a change in machine control operation. How we control the stock, how we know where is the stock now. When we catch the part with two spindles, we need to define on which spindle control this part. So open and close and release, those two modes are new, and you will learn how to use them. So here is the first example. From now, I want to control the part with the back spindle. The stock will be on the back spindle. It's the same as we said in the setup. Where is the stock now? I will start to work on main spindle, the checkbox that we used there. Now in MCO, I will use this new function. Close on stock. The part is now assigned to the back spindle. On main spindle, clamp open, and back spindle again, part move. I'm moving with the part, go to reference. Okay, we can see the part here clamped by the jaws and W-axis at the reference. Machine preview is very helpful to understand exactly what we want to do here. Help us with with the numbers to the position of axis that we can copy, paste, and everything else. Part move. Here, W-axis is at the reference, so we finish the transfer process. Let's see what's happened. I'm jumping to the machine control. This is the milling operation, retract of upper turret, and progress of W-axis with rapid, going with feed, clamping the part, and go to reference. That's correct. Now we can continue to work on the back spindle. In the same way, we define an operation very fast. And let's work with upper on back spindle, upper turret on back, a new geometry. On all this, you see, with only one coordinate system. From here to here to here, and I like to define the geometries one by one. That's my problem, but you can use all these new functions, options that we have now. I want to be in control of everything. The stock I define manually, and the target and everything else, as you already see. But each one of you with his own preference. Modify geometry. Okay, extend, and here I don't need any extension because I don't have any stock here. The tool. Again, when I want to select the tool, I'm using the mounting to see exactly what kind of tool I will select. For turning, we'll select this rough operation. We'll select this 80 degrees insert tool. Working here on 0 degrees. On 0, okay. Technology, rough, save and calculate. We have the operation. Save, select a new tool for the finish. Let's take tool number 2. I will use the focus on this tool. That's a 55 degrees. Again, mounted on a 45 degrees holder. Selection and working on 0 degrees, additional angle, levels, technology, finish only. And of course I can use compensation. And another operation, let's create for this drill. It's in a different angle. We will create a position, milling, drill. Let's create a position. center of this revolution face. Okay, and the geometry tool. I already have a drill here, tool 11. Let's see. It's a 5.1 millimeter drill mounted with an STL holder. Levels. Upper level should be somewhere here, 6.5, and drill depth somewhere here. It's should be 15. -1. Go down 1 more millimeter. Full diameter. Stock is absent. Okay, that's beautiful. Save and calculate. Stock is absent on the selected submachine table because what I select here, I didn't pay attention. I work on upper main. No problem. Upper back. Nothing changed. Coordinate system, the drilling, the geometry, the tool, levels, they are saved. I just save and calculate the position and everything is back. Everyone make mistakes, but you don't have to pay for them all the time. So today you get only a message and you are guided to how to fix this mistake in a very fast way. Let's try to simulate machine simulation. Sydney, you are with us.
Yes, I'm here. Don't worry.
Yeah, just final simulation and we are done here. If we have any questions, you can start reading them already.
Okay, we do have one question here. Talking about the tool library. How does a tool library and CAM deal with mill turn that has a tool magazine in addition to the turret? For example, we have a machine that has 10 stations in the turret and another 30 tools available in the magazine that are loaded into the turret when called with M6.
The tools, this upper turret that is defined here on this machine have a magazine. Now all the tools are defined and they are supposed to be in a magazine, but we don't see the magazine here. But every time we select a tool from the table, the tool is mounted, is like I use the M6 command and bring the tool from the magazine to the spindle and see the tool. So you see now I have a 55 degrees tool. It was in the magazine before. Now I will select the milling tool. Yes, it was in the magazine before. The upper turret have a magazine, but we don't show here magazine of this machine. Okay, but they are in the list. All tools, the 30 tools, 50 tools, depend on. We have machines with 120 tools magazine, but you will not see them in machine preview. Only when you select the tool is directly mounted on the spindle and you can see and check if everything is okay. For the lower turret, on lower turret, you see all the time all the tools. You don't have a magazine on this rotary turret. The tools are mounted in a fixed mode. It cannot be changed with an M6. So this is the difference between a rotary turret, a linear type turret, and a spindle type turret. The spindle type have a magazine. I think
Okay.
my answer was
Okay.
enough for
Okay,
you.
that's basically it for now. There aren't any real more questions at this moment. as far as the release date for SolidCAM 2016, which is one question that I would tell you to be in touch with your local reseller. He can give you more information about that.
Yeah, of course.
Okay, I think we are done for this week. And and stay tuned for our next webinar, which will be part two on SolidCAM 2016 Milturn. Florian, thank you very, very much. And I'm looking
My
forward to
pleasure.
your next webinar as well. Okay, take
Hope to
care,
see you again. Bye bye.
everyone. Okay, take care, everyone. Have a great weekend.